Hi everybody, it's David Porter, and today I want to cover some very basic statistics. It's important to understand the difference between correlation and causality. Getting the two confused is the cause of a great deal of junk science. A correlation is just a co-relationship or a link between two variables. That is a correlation. That does not mean that variable A produced variable B, but rather variable A and B are related or connected to each other in some way. They coincide with each other. Causality is a very different concept than correlation. With causality, there is an established link between variable A and variable B, and that variable A has directly resulted in the production of variable B. Correlation, statistical connection, or coincidence between two variables. Causality, variable A has produced or led to variable B. Here's what can go wrong when correlation and causality are confused. Back in, I think it was the mid to late 90s, a British surgeon published a professional journal article on a correlation between autism and vaccines. And the media got a hold of it and the public went wild. You had, to this day, parents and other people who believe that vaccines cause autism, and that is absolutely false. You have parents who are racked with guilt because they think they gave their child autism by having them vaccinated. There are parents who refuse to get their children vaccinated because they are fearful their child will get autism. And as a result, we are seeing a return of childhood diseases that had been eradicated due to vaccination. There have been outbreaks of measles and another one is pertussis, or whooping cough. There have been a return of childhood diseases that haven't been seen in over 50 years as a direct result of people feeling uncomfortable or fearful of getting their children vaccinated. Here are some problems with that study. Yes, there is a correlation between vaccines and autism in that children get vaccinated at about the same age that autism is first diagnosed. But that doesn't mean that the vaccine caused autism. It just means that the two events are in temporal proximity to each other. They occur at about the same time. There was an attempt to find causality, and one suggested type of causality or actual cause of autism, vaccine and autism, was the use of thimerosal, a mercury-based preservative in the vaccine. And it is a factual statement that thimerosal contains mercury, and it's a factual statement that mercury is a neurotoxin. However, the amount of mercury in the thimerosal preservative is too small to cause mercury toxicity, even with repeated vaccinations given concurrently or consecutively. You will get more mercury by eating a tuna fish sandwich than you will in getting the entire required number of vaccines. Thimerosal has also not been used in vaccines for, I can't give you an exact figure, but it's been for decades. And autism does not look anything even remotely like mercury toxicity. Let's go back to that study. That surgeon, with all due respect to him, went outside his lane by doing a research study on immunology that was not his area of expertise. And he also used a very small number of subjects. Here is a maxim in research. You have to have at least 50 subjects in order to get decent results. And I believe he used somewhere around 12 or 15. So there's so many holes in that research article that it's tattered. It's an example of very poor science, very weak science. But again, the media grabbed a hold of it, because here's the point I'll make repeatedly. The media is not there to educate or inform. The media is there to create fear and outrage, because fear and outrage sell. Let's make people very scared and very angry. Now we have their attention. And we can sell whatever it is we're selling. Airtime, clicks on our website. The media, legacy media, is a for-profit entity. They are interested in primarily in making profit get out of here. I'm allergic. Very inconsiderate bee to interrupt my video. Anyhow, the legacy media is a for-profit entity, and they sell fear and outrage. And you have too many members of the public who do not have adequate education about science or statistics, who don't understand probability and don't understand basic statistical concepts such as correlation and causality. And this is not just some theoretical or academic problem. It can create great harm, as in the example that I've just given. Okay, a couple of other important statistical concepts: reliability and validity. I mentioned earlier that in order for a study to be any good, you need at least 50 subjects. If you have less than 50 subjects, you are drastically decreasing the reliability of your findings. Validity and reliability. Validity asks or poses a question: does this test or this method or this measure what it's intended to accurately? For example, you step on a scale, it gives you weight, tells you your weight. It's designed to tell you your weight. If you put the scale in your mouth and bite down on it, it is not going to tell you your body temperature, because it's not designed to, it's not intended to. A scale is a valid measure of weight. It is not a valid measure of body temperature. A thermometer is a valid measure of body temperature. And here's something very important, everybody. Do not ever get the oral thermometer and the rectal thermometer confused. The first indicator of that is typically the taste. You want your device or method or test to be to be valid, but it also must be reliable. Reliability is, do you get consistent results repeatedly? If you step on the scale in the morning, it gives you a weight of, let's say, 250 pounds. And you step on it at noontime, and it gives you a weight of 235 pounds. Step on it before you go to bed, 275 pounds. The scale is still a valid measure of weight because it is doing its intended purpose. It is telling you your weight. However, it is no longer a reliable measure of weight, because you're getting readings all over the place that cannot be attributed to the normal fluctuations in weight due to fluid and food intake and waste excretion throughout the day. You're getting variability in the 25-35 pound range, which doesn't make any sense. Therefore, the scale is no longer a reliable measure. So, 4 basic statistical concepts: correlation, causality, reliability, and validity. Important to know those. Okay, everyone, thank you for watching. Please hit subscribe and be safe.